right, here we go. So we're going to do a review of some story problems using our trig ratios, sine, cosine, and tangent. So on the first problem, it says how long to the nearest foot is the cable that supports the pole? This didn't copy very well, so this is supposed to be x, this is supposed to be 50 degrees, and this is supposed to be 950 with a little foot mark. I apologize for the fact that that did not copy, but hopefully you can read what I just wrote and put that in. And then this is supposed to be a right angle, even though they didn't mark it that way. We are assuming that this pole is straight up and down. All right, so when you are using a picture and you're using trig, you're going to look at the angle that's given, the one that's not the right angle, the acute angle that's given, and the two sides that you're working with, and then you decide which trig function to use. So x is pretty easy. That's the hypotenuse. Which side is the 950 with respect to the 50 degrees? Is it? Adjacent. It's adjacent. So if we're thinking about SOHCAHTOA, we want to figure out which one of these is used as adjacent and hypotenuse. So adjacent and hypotenuse goes with cosine. So when you set these up, you always do the trig ratio and then the angle. So the angle is 50 degrees, and then it's going to be 950 over x. Okay? So when you're trying to get rid of a fraction and your variables in the denominator, we technically multiply. So this is 950 divided by x. We technically multiply both sides by x. I'm going to write that separate, but you can just put times x up above. So I'm multiplying both sides by x, and then I have x times cosine of 50 degrees equals 950, and we're trying to solve for x. So what we would have to do then is divide by cosine of 50. So let me rewrite this first. X times cosine of 50, make sure I'm being clear, equals 950. So we're trying to solve for x. Divide by a cosine of 50. And so we're going to have 950, that looks like 95 degrees, so let me fix that. Divided by cosine 50, so let me get my calculator up here. 950 divided by cosine of 50, and that looks reasonable. If this is 950 feet, this would be a little longer because that's the hypotenuse. So that comes, it says to the nearest foot, so that would be the nearest whole number. So we're going to say that is 1,478 feet. Since we have that 0.9, we're just going to round that up. On each and every problem, you want to make sure that you are rounding it off to whatever it says. All right, on number 2, it says how high to the nearest foot is the cliff. So they went ahead and put x on there, which is nice. They don't always do that. This is supposed to say 37 degrees. It's not very clear. That's x, and then the 300 we can see. So this is how high the cliff would be. So what sides are we working with respect to the 37 degrees? Which one is opposite? X. So x is the opposite side. 300 would be the adjacent side. So if we're thinking about
tangent.
So good. Okay, glad you guys remember the song. Okay, that's good. So tangent is right there. So tangent of 50 degrees is x. 37 degrees. So you guys are distracting me. You need to be quiet.
Look at what you did.
37 degrees is x over 300. So if we are going to solve that for x, what would I need to do?
Times 300.
Multiply by 300. So I'm going to have 300 times tangent of 37 degrees equals x. And technically you're multiplying this side by 300 too, which makes the 300s cancel. So if we put that into our calculator, 300 times tangent of 37 degrees, we get, and it says to the nearest foot again, so just be 226 feet. So 226 feet is what we're looking for. Okay, the ones that are trickier, I think, are the ones that have angle of elevation and angle of depression that do not give you a picture. So we're going to set up the picture on these. So a bird rises 20 meters vertically over a horizontal distance of 80 meters. What you want to do is draw a picture. So you got a bird. It's rising 20 meters vertically, so that's 20 meters, over a horizontal distance of 80 meters. I don't know if that looks 4 times as long, but whatever, it's just a picture. So up and over are going to be at right angles, and it says, what is the angle of elevation? So the angle of elevation, you're always going to have like your person down here looking, and it's the angle down here. So this is actually the x that we're looking for. It's always going to be with relationship to the horizon line. So we can find this angle, which I'll just call y, and then we can find this one by subtracting from 90, and so it'll be a couple of steps. So if we're setting up to solve for y, we start with the same thing. What sides did they give us? Opposite and adjacent. So there's opposite, there's adjacent. So it's tangent again. So I'm going to have tangent of y equals 80 over 20, which would just be 4. So tangent of y equals 4. And then how do we find the angle using our calculators? Do you remember?
No. Second tangent.
Good, second tangent. So what we're basically going to do is do second tangent of 4. So we're going to do second tangent of 4. It's going to look like this. You have to use your second key before you hit the tangent key. And then it will tell us what that angle is. So that's it. Does it say? It doesn't say. So we're just going to round to the nearest degree. So that'd be about 76 degrees. So y is about 76 degrees. So that is in here. 76 degrees is this y. So then to find x, these are going to make a right angle. So you're going to take 90 minus 76, and you will get 14 for this actual angle. So we spent a whole day on just how to set up angle of elevation and depression last year. This is sort of the abbreviated version, but I wanted to make sure we went through it and explained it's not this angle, it's that angle. Okay, so let's look at number 4. The length of a water ski jump is 720 centimeters. I don't know where I got 9. And the angle of elevation is 35 degrees. Find the height of the ski jump to the nearest centimeter. So that means this ski jump is set up on an angle. So water ski jump, I'm assuming, is set up in the water. I've never done this. Yeah, just do it on the land. It'll be fine. And so the length is 720. So that would be up here on the actual ramp. And it says the angle of elevation is 35 degrees. So that would be down here, because this water would be like your horizon line. And we're assuming this is a right angle. And it wants to know the height of the jump. So the height of the jump would be this part right here. We'll call that x. If it wanted to know how far horizontally you actually traveled, which would be a little less than 720, you could figure that out. Okay, so which trig function are we using?
We have opposite and adjacent.
We have opposite and hypotenuse. So if we're thinking about SOHCAHTOA, that would be sine, because you've got opposite and hypotenuse. So sine of 35 degrees is x over 720. I just realized my opposite looks like a number for a second, so I'm going to label that a little better. And then how do we solve that?
By 720.
Multiply by 720. So I'm going to have 720 times sine 35 equals x. We multiplied on both sides. That canceled this out. So we're actually going to type in 720 times sine of 35 degrees, making sure our calculators are in degree format, and we get 400, and it says to the nearest centimeter, so we'll just round it off to 413 centimeters. It's awful darn close. All right. So then down here, it says, how far below sea level to the nearest meter will a porpoise be if it swims 250 meters at an angle that should be at a 12-degree angle of depression? I guess it's right. My brain just didn't want to read it that way. So here's the water line.
Can you please draw a porpoise?
I cannot draw a porpoise. I wish I could. Okay, and it is swimming 250 meters down like this at an angle. And it tells us that that angle of depression is 12 degrees. So as long as we're making the 12 degrees with that horizontal line right there, we're good. And
It should be 250 meters.
meters instead of degrees. Thank you. I'm having one of those, senior moments. All right, so, and it wants to know how far below sea level will it be. So that's kind of like the height problem. It'll be over here. So we all, again, have, this would be your opposite side and your hypotenuse again. So we're going to use sine again. So sine of 12 degrees is x over 250. And we solve. So how would we solve that?
Times by 250.
Multiply by 250. So 250 times sine of 12 degrees. So 250 times sine of 12 comes out 51.97. So to the nearest meter, that would be 52 meters. A lot of times they don't use very many significant digits on a final answer. Sometimes they would have rounded that off to 50 and go, it's about 50, one significant digit.